Hello everyone, I'm Jonathan Beaton and I will present our work on WinoGAViL, Gamified Association Benchmark to Challenge Vision and Language Models. This is a joint work with my collaborators from the Hebrew University of Jerusalem, Ben-Gurion University, and UNC Chapel Hill. Vision and language models perform well in tasks like visual question answering, but they struggle in tasks that require human common sense. Many benchmarks have been proposed over the years, designed to be alternatives to the Turing test. For example, the Winograd Schema Challenge, WinoGrande, and many more. Initially, these benchmarks were very challenging, but with time, model performance quickly matched human performance. In this work, we introduced WinoGAViL, an online game to collect vision and language associations. Similarly to the Codenames game, spy masters give a textual cue related to several visual candidates, and another player has to identify them. We use the game to collect 3,500 instances. We find that while they are intuitive for humans, achieving over 90% Jacquard index performance, they are challenging to state-of-the-art AI models, where the best model, WILT, peaks at 52% on the difficult split that we have in the dataset. This is a dynamic benchmark that aims to stay relevant as AI develops. New players create challenging instances when they play our game. The players tend to invent complex social, cultural, and non-visual relations, and it makes our benchmarks less saturable compared to the previous benchmarks. Now let's take a look at the game. The task is to select the top 2 images that best fit the cube werewolf. In this example, the top 2 most associated images, as solved correctly by human annotators, are the images of the puppy and the moon. Now let's see how this instance was generated. A spy master, Alice, was asked to generate an association that fools an AI model, but will still be solvable by other human players. She is rewarded inversely to the model performance and according to the human performance. In this example, she managed to partially fool the AI model, while the generated associations were solved perfectly by 3 other human players. Our rival AI model used in the game is the CLIP RN50 model. Our scoring metric is the Jacquard index, which is the intersection divided by the union between the ground truth associations and the selected associations. In this example, the intersection is 1, the mountain peak, and the union is 3, the cone and the cheese. So first, the spy master creates a challenging association. Then, a rival AI model makes a prediction that the spy master received the full AI score. Then, 3 human players validate the created association, and the spy master received the solvable by AI score. Then, in the end of the spy master turn, his role changes to that of a solver. And as a result, we have automatic validation, since every player that played the spy master role also plays as a solver, validating associations created by other spy masters. For human annotation, we pay Amazon Mechanical Turk workers to play our game. We pay the bonus if the solvable by human score is above 80%, which grows according to the full AI score. For the final benchmark instances, we selected associations that were solved with over 80% Jacquard index. Here you can see an example from the Mechanical Turk UI. After creating the queue, the spy master sees the model predictions in real time, motivating them to create more challenging queue to fool the AI in the next time. We analyze the different reasoning skills and observed patterns in our dataset. This observed pattern is analogy. Although horn is not typically associated with a TV, in this particular example, the TV looks like it has horns. After collecting the dataset, let's see how models perform on it. We experiment with 5 and 6 candidates and also with 10 and 12 candidates. More candidates is more difficult because there is a lower chance of success. We see that the game allows collection of associations that are easy for humans with 90% Jacquard index but challenging for AI models, where the best model, WILT, peaks at 52% on the difficult split we have with 10 and 12 candidates. The paper includes many additional results: alternative data generation baseline, supervised experiments, textual model experiments, and more. One interesting analysis to share is evaluating model performance on different association types. We took 1000 Q image pairs and let annotators classify them to one of the following types. We see that models' performance varies between the different association types. We published this annotated data along with the annotation guidelines defined in the different categories. Check out our project website where you can interact, see the code, Hugging Face integration, explore the different associations created by human players, and you can also play, where you will see online model predictions in real time and also see the statistics for your game. Thank you very much.